Hi, I'm going to share some ideas on the Cartesian coordinate system. Geometry. In geometry, a coordinate system is a system that uses one or more numbers or coordinates to uniquely determine the points. The order of the coordinates is important. The coordinate system can be one-dimensional or two-dimensional or multidimensional. The real line. We can represent the real numbers in a horizontal line with the choice of an arbitrary point as origin or 0 point. We can mark point 1 to the right of 0 point with a unit length. Likewise, we can mark any real number in this number line. For example, this is point 3 by 4 marked on the number line. In geometry, a Cartesian coordinate system on a plane is a coordinate system that specifies each point uniquely by a pair of real numbers called coordinates, which are assigned distance to the point from two fixed perpendicular oriented lines called coordinate lines or coordinate axes or axes. The point where the axes meet is called the origin and has 0, 0 as coordinates. Here, red dot at the center is the origin. After fixing the origin, we can draw two perpendicular lines, horizontal and vertical, passing through the origin called x-axis and y-axis respectively. Both axes have the same unit length. There are four quadrants in the xy plane. First quadrant is at the top right, which has positive x-axis and positive y-axis. Second quadrant is at the top left, which has negative x-axis and positive y-axis. Third quadrant is at the bottom left, which has negative x-axis and negative y-axis. Fourth quadrant is at the bottom right, which has positive x-axis and negative y-axis. If P lies in the x-axis, then y is equal to 0, and if P lies in the y-axis, then x is equal to 0. For example, this is the point 4, minus 2 marked on the xy plane, and this is point minus 5, 0 marked on the xy plane. Distance between two points in a plane. The distance between two points equals the square root of the sum of the squares of the differences of their coordinates. Let P1 is equal to x1, y1 and P2 is equal to x2, y2. Then by Pythagoras theorem, the distance between two points can be given by root of x1 minus x2 the whole square plus y1 minus y2 the whole square. For example, here x1, y1 is 3, 2 and x2, y2 is 10, 8. So the distance between two points is square root of 85. Slope. It is an expression of steepness with which the line goes upwards or downwards as we move to the right. A line that ramps downwards as we move to the right has a negative slope, and a line that ramps upwards as we move to the right has a positive slope. If P1 is equal to x1, y1 and P2 is equal to x2, y2 or any two distinct points on a line, then the slope of the line M is defined as ratio of difference of y coordinates and x coordinates. From previous diagram, it is triangle's height by base. If M is equal to 0, it is horizontal line. If M is greater than 0, line rises to the right. If M is less than 0, line falls to the right. For example, here point P1 is 3, 2 and P2 is 10, 8. So the slope is 6 by 7. Equation for straight lines. A vertical line has the same x coordinates for all points in the line. The horizontal line has the same y coordinates for all points in the line. So the equation of a straight line can be like x is equal to a or y is equal to a for vertical or horizontal lines. For example, x is equal to 2 is a vertical line and y is equal to 4 is a horizontal line. For lines with non-zero slope, the equation can be given from the slope formula m is equal to y minus y naught by x minus x naught, where m is the slope of the line, is called point slope equation. For example, a line with 2 points 2, 4 and 8, 10 where slope is 1 when x naught, y naught is taken as 2, 4, the equation is given by x minus 2 is equal to y minus 4, that is x minus y is equal to minus 2. If we consider the x naught, y naught as 0, b, that is a point on the y axis, then the equation becomes y is equal to mx plus b, where b is called y-intercept and the equation is called slope-intercept equation. Two lines are parallel if and only if slopes are equal, that is m1 and m2, where m1 and m2 are the slopes of first and second line respectively. For lines to be perpendicular, then criteria is m1 into m2 is equal to minus 1. For example, a line with points 0, 2 and 8, 10 where slope is 1 and y-intercept is 2, the equation is given by y is equal to x plus 2, that is x minus y is equal to minus 2. Equation for circles. A circle with center C of h, k and radius r is defined to be all points with distance r from C. If coordinates of a point is x comma y, then by distance formula r equal to square root of x minus h the whole square plus y minus k the whole square. If center is origin, then x square plus y square is equal to r square. For example, if center is 8 comma 5, then the equation is x square plus y square minus 16x minus 10y is equal to minus 64. Radian. Angles can be measured in many different ways. Most commonly used ways are degrees and radians, where 1 degree is 1/98th of a right angle. If S is the length of the arc subtended by the sides of the angle theta with length r from a point, then the magnitude in radians theta of a subtended angle is defined as theta is equal to S by r. Since circumference of a circle is 2 pi r and semicircle is pi r, if arc length S is equal to pi r, then theta is equal to pi r by r, that is pi radians. So 180 degrees is pi radians. These are the radian measurements of few angles. Sine of the angle. Angle is formed between two lines having common endpoints called vertex, in which one side is designated as the initial side and the other side as the terminal side. Generally, the angle produced by counterclockwise rotation is positive and clockwise rotation is negative. For example, the angle between the positive y-axis and the line in the first quadrant is 45 degrees in the counterclockwise direction. The angle between the positive x-axis and the line in the third quadrant is 315 degrees in counterclockwise direction, but in clockwise direction it is minus 45 degrees. Rotating a point about the origin. When a point x, y is rotated by theta angle in counterclockwise direction about origin, the new point x1, y1 is given by the formula x1 is equal to x into cos theta minus y into sin theta, y1 is equal to x into sin theta plus y into cos theta. For clockwise rotation, x1 is equal to x into cos theta plus y into sin theta, y1 is equal to minus x into sin theta plus y into cos theta. For example, when point 0, 5 is rotated by 60 degrees in counterclockwise direction, the new point will be minus 4.33, 2.5. But when the same point 0, 5 is rotated 30 degrees in clockwise direction, the new point will be 2.5, 4.33. Let's draw a perfect clockwise. First, we fix the origin at the center of the box. Then we can draw two perpendicular lines passing through the origin. The horizontal line is called x-axis and vertical line is called y-axis. We can draw a circle with origin as center and 10 units as radius that represents the clock. Now, we can draw a smaller circle with radius zero point 0.5 units at the center of a bigger circle about which the clock hands will rotate. Drawing circles is easy. We just have to fix a point for the center of the circle and fix a radius for the circle. Now, we can write numbers inside the clockwise. A full rotation starting from any line to itself is 360 degrees angle. Since there are 12 numbers inside the clockwise, we have to write a number every 30-degree angle. Instead of numbers, we can use dots. We can start from the positive y-axis. We can place a dot at the length less than the radius of the bigger circle from origin in the positive y-axis. Say, if radius is r, we can place the dot at 0.9 into r, that is 90% of radius. Now, number 12 is placed at the point 0, zero zero 0.9 into r. For number 11, we have to rotate this point about origin by a 30-degree angle in clockwise direction. The new point will be 4.5, 7.94. Similarly, we can place dots at every 30-degree angle from number 1 to number 11. Now, we have to place 3 clock hands. We can get hour, minute and second values from the chosen time. We can choose the time 2 hours, 15 minutes, 45 seconds. We have to place the hour hand. Number 2 is at 60 degrees away from the positive y-axis. If time is exactly 2 hours, 0 minutes, 0 seconds, then we can draw a line from the origin at an angle 60 degree from the positive y-axis in the clockwise direction of length say 0.5 into r, that is less than the radius of the bigger circle. Since the time is not exactly 2, we have to rotate the hour hand according to the number of minutes and seconds passed. The angle of rotation can be calculated as 2 into pi by 6. plus 15 into pi by 6 into 60 plus 45 into pi by 6 into 60 into 60. Here pi by 6 is 30 degrees. There are 360 degrees and 12 hours. So 1 hour corresponds to 30 degrees. The first part before the plus sign gives the value 60 where number 2 is present. In the second part, the angle 30 degree is divided by 60, that is zero point 0.5 degrees is multiplied by minute value 15. In the third part, the angle 30 degrees is divided by 60 into 60 and multiplied by second value 45. Finally, the three values are added. For minute hand, we have to calculate the angle of rotation by using this equation 15 into pi by 30 plus 45 into pi by 30 into 60. Here, in the first part before the plus sign, the angle 6 degrees is multiplied with minute value 15. Since there are 360 degrees and 60 minutes, so 1 minute corresponds to 6 degrees. In the second part, angle 6 degrees is divided by 60 and multiplied by second value 45. Finally, both values are added. For second hand, we have to calculate the angle of rotation by using the equation 45 into pi by 30. Since there are 360 degrees and 60 minutes, so 1 second corresponds to 6 degrees. We have successfully created the clock face. Thanks. If you find this video valuable, you may share it with others. If there are mistakes, please mention them in the comment section.